All right, let's start off by multiplying binomials. Binomials have two terms, two terms. So let's take a look at number one. That should be a fairly easy one. FOIL method, which is really just using the distributed property twice, is what it amounts to, okay? FOIL. First, meaning the first terms in each parentheses. Outer, meaning the outer terms of the four that you see there. Inner, meaning the two inside terms of the four you see there. And last, meaning the last term of each parenthesis. But it's really just the distributive property twice. Once, using the m, so first, distribute that m, first term, m times m squared. And then the O, the outer, is the same thing as still just distributing that m times 1 is m. I for inner. Now we're distributing this 4. 4 times m is 4m. L for last. Now we're still distributing the 4. 4 times 1 is 4. And expect, out of those 4 terms you have as your result, expect the 2 in the middle to be like terms. So we'll get m squared plus, all right, m plus 4m is 5m plus 4. All right, so does that ring a bell? All right, good. Let's take a look at number 11. Let's do this one. So we multiply 3n times n and get 3n squared. And by the way, you don't have to draw the arrows, and I will stop eventually, okay? Then we multiply 3n times 3, and we get 9n. Now, negative 7 times n is negative 7n, and negative 7 times 3 is negative 21. So the sign remains attached to the term when you turn it into a factor and multiply, okay? Don't leave off the signs. I don't know what you were taught throughout your math life, but minus signs and negative signs are the same thing. Even though most calculators have a negative sign instead of a minus sign when you do negative on a number, in the real world, minus signs and negative signs are the same thing, because that minus 7 just means plus negative 7, okay? So minus signs and negative signs are the same thing. So what do we got? Well, we've got the 3n squared, and then 9n, a positive 9n and a negative 7n gives us a positive 2n, and then we have negative 21. And then don't shy away from the ones that may cause a little more of a challenge, like number 21. So let's take a look at this one. We can't call this one the FOIL method, can we? Because there's 3 terms in the second parentheses. It's a binomial times a trinomial. But it's still the distributive property twice, once with the k, once with the 4. So first, let's distribute the k. K times k squared is k cubed, and then k times 3k is 3k squared, and then k times negative 6 is negative 6k. So that's what we get when we distribute the k. Now we have to distribute the 4. So 4 times k squared is 4k squared. 4 times 3k is 12k. And 4 times negative 6 is negative 24. And now let's look and see how many like terms we have to combine. Are there any other k cubed terms? Just the one, k cubed. How many k squared terms do you see? 2 of them, a 3k squared and a 4k squared, and they're both positive. So that's a positive 7k squared. How many k terms do we have? 2, a negative 6k and a positive 12k. So when we combine those, we get positive 6k. And then, are there any constants? 1, negative 24. Constant is a term with no variable in it. All right? All the vocabulary I'm using, words you're familiar with? Okay, good. Now, while you're working these, not necessarily the ones like 21, but the binomial times a binomial, our goal tomorrow, Monday, whenever the next day is to be able to do this backwards and factor. Okay? So next time we'll start with m squared plus 5m plus 4 and end up with the quantity m plus 4 times the quantity m plus 1. So as you're working these, don't be so concerned with flying through here, getting the answers. I want you to notice some things about what things are multiplied together, where that middle term comes from, the signs. Sometimes you have negatives, sometimes you have positives. I want you to notice those things so that when I point them out later on, you'll be like, oh yeah, I noticed that. Okay? All right. On page 2, you have more of the same. Let's do number 9. Because we need to be able to do ones with 2 different letters in it too, 2 different variables. So on page 2, number 9. 3a, FOIL method, or distributive property twice. So we start off 3a times 2a. Now, whenever you have coefficients, you got to multiply those together, right? So 3 times 2 is 6, and then your variables, a times a is a squared. So 3a times 2a is 6a squared. And then 3a times negative b, what is 3a times negative b? Negative 3ab. Now we distribute the negative b. What's negative b times 2a? Negative 2ab. And then last, negative b times negative b? Positive b squared. Now, it is conventional notation to, when you have 2 variables in one term, to go alphabetically. All right, it's not incorrect if you'd put negative 3ba, but it's definitely unconventional. So negative 3ab, okay? Now, are there any like terms to combine? Yeah, almost always the 2 in the middle are going to be like terms. So 6a squared. Now, negative 3ab and a negative 2ab. Combine your coefficients and you get negative 5ab and then plus b squared. So again, as you're doing these, be thinking about how would I go backwards? Okay? That means you can't ignore that. You've got to think after you get one done, how would I go backwards? Okay? Page 3. Squares of sums and differences. In other words, squaring a binomial. Because if you've got 2 terms, they're either going to be a sum or a difference. There's either a plus sign between them or a minus sign between them. Okay? So if I'd been the author of the book, I would have called this squaring a binomial. Okay? Squaring a 2-term polynomial. All right. It works this way. You can use the FOIL method. You can just simply rewrite that as x minus 6 times x minus 6, and you'll be fine. It'll work. Do it just like we did the other examples. You'll get the right answer. Okay? But there's also a technique, and it's this. Look at this one. If it's a plus sign between the 2 terms, your answer turns out to be the first term squared plus 2 times the first term times the second term plus the second term squared. And if it's a minus sign between the 2 terms, look what your answer turns out to be. The first term squared, this time it's minus 2 times the first term times the second term plus the second term squared. Those two answers are identical except right there. And how do we know what sign goes right there? If the sign in your binomial is a plus, that's what goes as the sign of your middle term. If the sign in your binomial is a minus, that's the sign in front of your middle term. All right? So I use this all the time. This evidently has kind of fallen out of favor, but it just saves me so much time because you guys get to calculus or statistics or pre-calculus or college algebra, you need for these kinds of things not to take up a lot of brain power. Okay? They can right now, but in the future they can't take up too much brain power. You got bigger things to worry about. So, number one, if I'm fitting this formula, it would be the second one because there's a minus sign between the two terms. A would be x, B would be 6, wouldn't it? But I don't really memorize it as A and a B. I remember it as first term, second term. So whenever you square a binomial, it's the first term squared, x squared, since it's a minus between the two terms, minus, hang on, now, 2 times the first term times the second term. For using the little formula to save us any work, we need to do that in our head. 2 times the first term times the second term. And we've already taken care of the sign. It's negative. So we don't have to worry about that. So 2 times x times 6. Well, what is 2 times x times 6? 12x. Plus, it's always plus. The second term squared. What's 6 squared? And there, we made that a one-step problem by knowing how it always works out. Okay? And I called it a formula, and I don't really mean that. It's not really a formula. It's an algorithm. It's a technique where we notice the answer always works out the same way. So we're just kind of skipping the middle part because we know the answer always works out the same way. Okay? All right? Let's see. Let's do, how about number 16? Looks a little tougher. Number 16 is a binomial squared. So we should get the first term squared. Now, what do you get when you square x to the third? X to the sixth. Remember, it works this way. An exponent to an exponent, you multiply exponents. X to the sixth. There's a minus sign, so we know our middle term's negative again. Then it's 2 times the first term times the second term. 2 times x cubed times 1. What's 2 times x cubed times 1? 2x cubed plus, it's always a plus, the second term squared. 1 squared. 1. And let's take a look at 21. Fractions tend to be scary for some of us. I don't want them to do all negative. Let's do 18. That way we're doing one that doesn't have a minus sign in them. All right, so I'll write my answer down here while I have room. So for number 18, that is a binomial squared. So first term squared. What do you get when you square 1/4 x? In other words, what's 1/4 x times 1/4 x? 1/16 x squared. This time, since the sign between the two terms is a plus, it's plus 2 times the first term times the second term. 2 times the first term times the second term. 2 times 1/4 x times 3. Well, what's 2 times 1/4? 1/2. What's 1/2 times 3? Instead of 1.5, though, let's write it as a fraction. 3/2. You have mixed numbers, no good. Improper fractions. And what have I almost forgotten? The x. All right, it was 2 times 1/4 x times 3. Plus, because it's always a plus, second term squared. 3 squared is 9. Now, our answers to these are all called perfect square trinomials. You can see the trinomial, right? Because doesn't every answer have 3 terms in it? So they're trinomials. Why are they called perfect squares? For the same reason a number is. 25 is called a perfect square because it's equal to 5 squared. These are called perfect squares because they're equal to another polynomial squared. Okay? These things actually have square roots. If we had to find the square root of 1/16 x squared plus 3/2 x plus 9, it would equal 1/4 x plus 3. Ooh. Okay? And the last thing we're going to work on today. Product of a sum and a difference. These are all binomials, and look what they are. Just look at the worksheet for a second. Notice that the two binomials are identical except for the sign between the terms, okay? And by the way, little extra learning. Those are called conjugates of each other. The conjugate of x plus 4, of x minus 4, is x plus 4. The conjugate of x plus 4 is x minus 4. Okay? So a pair of conjugates are identical binomials except for the sign between the two terms. So now you know what a conjugate is. All right, so these can be worked out really easily. And again, you can do the FOIL method. But whenever they're two conjugates, whenever it's a sum and a difference of the same two terms, your answer is always that. It's always the first term squared minus the second term squared. So these problems can be really short and really quick. So for number 1, first term, x squared minus second term, 4 squared. Okay? So again, you can get through life and through math without using this technique, but it's a real time saver. Plus, I think you're actually less likely to make a mistake because if you do the FOIL method, you've got more steps. You're more likely to make a careless error, I think. I am anyway. Okay? Now, the variable doesn't have to be in front. Look at number 8. It's still a sum and difference of the same two terms, okay? So it's still the first term squared. 3 squared is 9. Minus the second term squared. What do you get when you square 5q? 25q squared. Or we can even have two variables, and they can even have exponents on them. Look at number 17. H squared is your first term. K squared is your second term. One binomial has a minus sign between them. The other one has a plus sign between them. All right, so first term squared. H squared squared. H squared squared, h to the 4, minus, so then what's k squared? Squared, k to the 4. Yeah, so don't switch them. Okay? Yeah, because, don't put 25q squared minus 9. That's not the same answer. So, yeah, you got to do first term squared minus second term squared. Got to be. Okay? Now, all of these answers are called a difference of two squares. Difference. Fraction. Two squares. Two squares. Because x squared is a square, 16 is a square, 9's a square, 5q squared is a square. They're all something squared. Okay? So it's a difference of two squares. Now, again, as you're working these, be able to think, how would I do this backwards? Think to yourself, if I'm faced with a problem of that and I'm told to factor it, which is the going backwards process, what would I do? What do I need to notice? Same thing there. Same thing there. Okay? Be thinking about, how would I do this backwards? Okay? Any questions?